Okay, so this is how this feels like to be on this side. Yeah, my name is Christian. I'm a PhD student here at SLU at the Department for Forest Biomaterials and Technology. And I'm here to just briefly mention a few points about my PhD project. And like many of the presentations I've seen today, it's about computer vision or machine learning or deep learning or whatever you want to call it. Computer vision is a subset of machine learning, which is about, taking the human ability to see and trying to combine that with the computation power of computers, right? So you can use this, for example, tree detection, obstacle detection, species identification, and so on, which some of you have mentioned today. And for the forest operations point of view, we can piggyback a bit on larger domains development in these kinds of model architectures and models. But we need to bring our own data. And why do we need to bring our own data? The model is a computer vision model needs images to be trained on and to be evaluated on. Image data domain specific, and since there are kind of a lack of image datasets from the forest, that's what we're here to. What I'm trying to fix a bit, and these models resulting from better labeled data could enable a larger degree of operator decision support and further automation in the forest operations. So a deep learning model or machine learning model for computer vision typically requires quite a large data set, so many images. They need to be diverse to capture all elements of what it's going to infer on later. The labeling needs to be correct and consistent, as mentioned earlier, and also ideally cover edge cases. So there's been a few previous efforts and really good efforts to curate these kinds of data sets. I mentioned just a few recent here, and it's all great, and they've been collecting images for use in training computer vision models. So why would we need another one? Why would we? As I said, we need a data set to be large and diverse and have all these edge cases in it. And these data sets out there has a lot of these features, but they are limited in scope, usually. They're limited to a study that was done in a certain season, or you did your data collection on a day when it wasn't raining and stuff like that. So you remove a lot of the variability that you see in the real world for the first operations machines. So if we can put a camera on a forester machine that you can continuously or intermittently record, then you will catch all this variability and these edge cases, presumably. But that will end up there will be a lot of data to do annotation on, which is a very labor-intensive part of creating these annotated data sets. So we're thinking that we already have operators in harvesters today basically annotating data via Stanford, because they annotate what kind of tree they are processing. So if we can tap into that data stream, we could lift that annotation and put it onto the video feed. And that way, we can annotate a large scale image data set, fast, cheap, and hopefully with, well, at least consistent labels, hopefully correct ones as well. And this data set, since being deployed in potentially several harvester machines across geography, we can assume it would scale over time. So that's what we're thinking about in this PhD project. It's a work in progress, but we really want to make an effort to integrate all this great technology into the forestry operation. Yeah, that's a quick flash thing of what I'm doing. I'll happy to take a few questions and catch me outside somewhere and talk about cool stuff, as Ola called it earlier.
Yeah. Okay, so thank you, Christian. We have questions.